China already produces 960.8 million metric tons of steel every single year. That is more than every other nation on Earth combined. You heard that right. Every American mill, every German forge, every Japanese plant, every Indian furnace, all of them added together, and China still outproduces the entire rest of the world by itself. And that is just the beginning. Because here is the part that blows most people's minds. China is not winning by making more steel than everyone else. China is winning by making steel itself unnecessary. 3 separate technologies developed simultaneously, and the West does not yet fully understand what it is watching. That starts with a thread thinner than a single strand of your hair. The thread replacing everything. Picture a single strand of your hair. Hold that image. Now imagine something thinner than that. So thin you could barely see it under normal light, that is stronger than steel and lighter than aluminium. Not in a laboratory, not in a prototype, in mass industrial production, right now, at a scale no other country on Earth has matched. That is what China just did. In March of 2026, China's state-owned CNBM, through its carbon fiber unit Zhongfu Shenying, announced stable industrial production of what engineers call T1200 grade ultra-high-strength carbon fiber. The internal designation is SYT-80, and the number that matters is 1200. That is the tensile strength classification. For context, the carbon fiber most commercial aircraft use today sits around the T700 to T800 range. China just crossed T1200 at industrial scale for the first time anywhere on Earth. You heard that right. Not a Western lab, not a European aerospace contractor, China. Now, most people never think about this, but carbon fiber is not one thing. Think of it like bread. A basic loaf and an artisan sourdough are both bread, but the ingredients, the process, the structure, and the result are completely different. T700 carbon fiber and T1200 carbon fiber are both carbon fiber the same way. The gap between them is not incremental, it is structural. The internal alignment of the carbon molecules at T1200 grade is so precise, so controlled, that the material behaves almost nothing like what came before it. Here is what that actually means in the real world. Aircraft frames, pressure vessels, wind turbine blades that need to spin for decades without fatigue. Next-generation vehicle structures, where every gram of weight saved translates directly into range, speed, or fuel efficiency. Every single one of those industries has been waiting for this material to exist outside of a research paper. And now it does. In China, at industrial volume. Here is the detail that engineers don't want to admit out loud. The West has been trying to crack T1200 grade production at scale for years. The science is understood. The challenge is not theoretical. It is manufacturing. Maintaining the precise temperature gradients, the tension controls, the chemical environment across thousands of meters of continuous fiber production without a single inconsistency that degrades the final grade. That is the wall. And Zhongfu Shenying just walked through it. Western aerospace manufacturers, the ones who supply Airbus, Boeing, the defense contractors, they are still sourcing the bulk of their high-grade carbon fiber from a handful of Japanese producers. Toray, Teijin, names that have dominated this space for decades. Those companies are extraordinary. They built the modern carbon fiber industry almost from scratch, but they are operating at T800. And the world just moved to T1200. China did not just catch up to the frontier. China moved the frontier. But a revolutionary new fiber is only one piece of what China just unleashed. Because at the same moment this was happening above ground, something far stranger was happening inside the steel itself. Steel that isn't steel anymore. You have probably held a car door before. Maybe you have noticed how thin modern car panels feel compared to vehicles from 20 or 30 years ago. There is a reason for that. And the reason is not cost-cutting. It is a material that most people have never heard of, being produced at a scale that is quietly reshaping every industry that builds with metal. It is called third-generation advanced high-strength steel. And it is not an upgrade to conventional steel. It is a different thing entirely. Here is the best way to think about it. Regular steel is like a crowd of people standing in a field, loosely arranged, moving the same general direction, but with no real coordination. Third-generation advanced high-strength steel is like a military formation. Every element in the internal crystal structure is placed deliberately. The microscopic architecture is engineered, not left to chance. And that control at the grain level is what produces something that seems physically contradictory. A metal that is simultaneously stronger and more flexible than anything traditional steelmaking produces. Stronger and more flexible. At the same time, in the same material. That matters because in conventional materials, science, strength and flexibility trade off against each other. Make steel harder and it becomes brittle. Make it more flexible and it loses load-bearing capacity. Third-generation advanced high-strength steel breaks that trade-off, and China is now producing it at industrial volume. Here is what that looks like in practice. Volkswagen has already dropped car body weight by 27% using it. 27%. On a vehicle that previously took decades of incremental engineering to shave single-digit percentages off, Hyundai cut floor panel weight by 30%. These are not small optimizations. These are structural leaps, and they are happening because Chinese mills are supplying this material at prices Western producers simply cannot match. Here is the brutal catch for Western manufacturers, and this is the part nobody talks about openly. Chinese producers are already shipping third-generation advanced high-strength steel at 15 to 20% below comparable Western prices. That gap alone would be painful. But the real problem sits underneath it. To build a single competitive production line for this material, you are looking at a minimum capital commitment of $300 million per line. And the cost disadvantage Western mills face per ton runs between 35 and 45% before that line produces a single unit. Private capital will not make that bet. The numbers do not work. By the time a new Western facility opened, Chinese producers could undercut the finished price before the first coil shipped. Respectfully, Western steel mills built the modern world. The infrastructure you drive on, the buildings you work in, the ships that moved global trade for a century that was them. That legacy is real, but the material they perfected is no longer the material the next century of manufacturing requires. And that was just the ground level of what China built. The real trap was set somewhere far more dangerous inside the environmental regulations the West wrote for itself. The green trap, the West set itself. Imagine you spent decades building the most efficient fossil fuel furnace on Earth. You invested billions. You trained entire generations of engineers around it. You made it cleaner, faster, more precise. And then the rules changed. Not because a competitor beat you on efficiency, because the world decided the emissions your furnace produces are no longer acceptable. And while you were perfecting your furnace, someone else was quietly building a completely different kind of furnace, one that emits water instead of carbon dioxide. That is not a hypothetical. That is exactly what is happening right now. In late 2025, China's Baowu Steel Group completed a 1 million ton capacity hydrogen direct reduction iron and electric arc furnace production line in Zhanjiang. 1 million tons. That is roughly the entire annual steel output of a mid-sized European nation produced through a process that replaces coal with hydrogen and emits water vapor instead of carbon dioxide. You heard that right. Water. Here's what most people get wrong about green steel. They think it is a future technology, something being piloted in a Swedish research facility, something 10 years away from commercial relevance. Baowu just proved it is not. 1 million tons of annual capacity is not a pilot. It is not a demonstration project. It is an industrial commitment, and it is already running. Now here's the part that makes this genuinely devastating for Western producers. The European Union has been building towards something called the Carbon Border Adjustment Mechanism. The logic is straightforward. If European steel producers pay a carbon price on their emissions, then imported steel should face an equivalent tariff based on its own emissions footprint. Otherwise, European manufacturers just buy cheap carbon-heavy steel from abroad, and the whole system falls apart. The EU designed this as a shield for its own producers, a way to level the playing field, and it will do exactly the opposite. Because when those carbon tariffs kick in, Chinese green hydrogen steel will enter European markets with a dramatically reduced tariff burden. Its emissions footprint is genuinely low. The math works in its favor. Meanwhile, traditional Western blast furnace steel, the kind that still dominates production from Pennsylvania to the Ruhr Valley, faces carbon costs at home through domestic emissions regulations, and carbon costs abroad through the very mechanism designed to protect it. Western producers get squeezed from both sides simultaneously by rules their own governments wrote. Here is the detail that puts everything into perspective. The transition to hydrogen-based steelmaking is not cheap. The capital requirements are enormous. The infrastructure for green hydrogen supply at industrial scale barely exists in most Western countries, but China did not wait for the infrastructure to mature before committing. Baowu built the production line first. The supply chain will follow the demand. That is how China operates. That is not how Western capital markets operate. And here is what makes this chapter of the story particularly uncomfortable. The green steel advantage is not just a commercial edge, it is a regulatory one. China is positioning itself to be carbon compliant under Western rules before Western producers can afford to be. But the trap runs deeper than any single regulation. Because underneath all three of these material revolutions, the carbon fiber, the advanced steel, the green hydrogen production, there is a supply chain layer that most analysts barely mention. And it is the one that makes catch-up structurally difficult regardless of how much money the West decides to spend. The chokehold nobody mentions. Think about a world-class kitchen. The chef is brilliant. The equipment is state-of-the-art. The recipes are perfected over decades. But every single ingredient, the salt, the spices, the oils, has to be ordered from one supplier. One supplier who also happens to own the best restaurant in town and is competing directly against you. That is the position Western advanced steel manufacturers are in right now, and most people have no idea. Here is what makes advanced high-strength steel possible at the molecular level. Not the furnaces, not the rolling mills, not the engineering teams, the alloying elements, vanadium, manganese, niobium. These are not household names, but they are the ingredients that allow steelmakers to engineer those precise internal crystal structures we talked about earlier. Without them, third-generation advanced high-strength steel is not possible. Full stop. And China controls the dominant global processing capacity for all three. Let that settle for a moment. Vanadium refining China dominates. Manganese processing China dominates. Niobium is one of the few areas where the raw ore is largely mined outside China, primarily in Brazil. But the processing capacity, the refining infrastructure, the supply chains that turn raw ore into the precise industrial-grade inputs and advanced steelmaking requires China has built dominant positions across all of it. Here is the brutal reality this creates. Imagine a Western government, say the United States or Germany, decides today to invest seriously in domestic advanced high-strength steel production. They commit the capital. They build the production lines. $300 million per line, multiple lines, billions in total. They train the engineers. They solve the manufacturing challenges. And then they go to source the vanadium and niobium inputs. Their brand new state-of-the-art facility needs to actually run. Where do they buy them? In significant part from Chinese refiners, the very competitor they built the facility to challenge. Most people never think about this layer of the problem. The conversation always centers on production. Who has the factories? Who has the technology? But the factory is only as independent as its input supply chain. And on advanced steel inputs, the West does not have an independent supply chain. It has a dependency. Now here is the part that makes this more than just uncomfortable. It makes it strategic. China did not stumble into these processing positions. The dominance in vanadium, manganese, and niobium refining was not an accident of geology. It was built deliberately over decades. China identified which materials would sit at the base of next-generation manufacturing. Then it built the processing infrastructure for those materials while the West was focused on the finished products those materials enable. That is the difference in the approach. The West optimizes for the product. China secures the inputs. Here is what makes this incredibly difficult to unwind. Processing infrastructure takes years to build, requires its own specialized supply chains, and needs consistent industrial demand to be economically viable. You cannot build a vanadium refinery speculatively. You build it when you have guaranteed offtake. And right now, the guaranteed offtake for advanced steel inputs flows through Chinese industrial planning, not Western market signals. Western producers are not just behind on technology, they are behind on the ingredients that make the technology possible. But the supply chain chokehold is still not the deepest layer of this story. Because China did not just build the factories and control the inputs, it did something that will outlast both. It started filing the patents. The patents changing everything. You have probably heard the phrase, "He who makes the rules wins the game." In manufacturing, the rules are written in patent filings. And right now, China is writing them faster than anyone else on Earth. Here is how to think about this. A patent is not just a legal document. It is a moat. It is a wall built around the most efficient method of doing something. Once that wall exists, anyone who wants to use that method, regardless of where they are in the world, regardless of how much capital they have, either pays to cross it or finds a less efficient path around it. In advanced materials production, less efficient paths mean higher costs. Higher costs mean less competitive products. Less competitive products mean lost markets. China now accounts for a substantial and growing share of new green steel and advanced carbon fiber patents filed globally each year, not applications that go nowhere. Filed, active patents covering production methods, material compositions, processing techniques, and manufacturing processes that represent the current frontier of both industries. Here is what most people get wrong about this. They assume patents are a defensive tool, a way to protect something you already built. But at the frontier of a new technology, patents are offensive. They define what the efficient path looks like before competitors have fully mapped the territory. China is not just protecting what it built. It is legally enclosing the most efficient routes to what everyone else is trying to build. Think of it like this. Imagine a mountain range with dozens of possible passes through it. The fastest, lowest altitude pass is the obvious one. Everyone wants to use it. China filed the patent on that pass. And the next two most efficient ones, Western manufacturers are not blocked from crossing the mountains. They just have to climb higher, spend more, and arrive later. The carbon fiber patents are particularly significant. T1200 grade production involves extraordinarily precise manufacturing methods. The temperature controls, the chemical bath compositions, the tension profiles during fiber drawing, each of those is a patentable process step. Zhongfu Shenying did not just achieve T1200 production. It achieved it through specific methods that are now legally protected. Any Western manufacturer trying to replicate that production capability either licenses those methods or invents a different path to the same outcome. Inventing a different path takes years and carries no guarantee of success. Here is the detail that engineers don't want to admit. The patent wall does not stop Western production, but it raises the floor on what Western production costs. And in a commodity-adjacent market like steel and structural materials, the cost floor is often the entire competition. Now add this to everything else. China controls the inputs through refining dominance. China controls the production methods through patent portfolios. China controls the price through scale advantages that took decades to build. The West is not facing a single competitive challenge it can address with a targeted investment. It is facing a system. And systems are not beaten by solving one piece of them. But here is the thing. As significant as any single one of these advantages is the carbon fiber breakthrough, the advanced steel pricing, the green hydrogen production, the input supply chains, the patent walls, none of them is the real story on its own. The real story is what they reveal when you see them together. And that is where this ends up, somewhere far bigger than steel. How China planned all of this. Here is what most people miss. When they look at everything China has built in materials science, they see a collection of separate achievements. A carbon fiber breakthrough here, a green steel facility there, a patent portfolio growing quietly in the background. They look at the pieces and see coincidence, or they see speed, or they see scale. What they are actually seeing is sequence. Think about the difference between someone who wins a chess game because their opponent made mistakes and someone who won because they planned 12 moves ahead from the opening. The board looks the same from the outside. The result looks similar, but one of them was always going to end this way. China did not stumble into dominance across 3 simultaneous material revolutions. It mapped the destination first. Then it built backward from that destination to identify every input, every process, every legal protection, every infrastructure investment that the destination required. And then it executed that map over decades, across administrations, across 5-year plans, with the kind of continuity that democratic market economies structurally struggle to match. Here is what that looked like in practice. In the 1980s and 90s, China identified carbon fiber as a strategic material, not because carbon fiber was commercially dominant then, it was not, but because the industries it would eventually dominate, aerospace, defense, clean energy, advanced vehicles, were clearly going to matter in the century ahead. So China began training materials, scientists, funding research institutes, building relationships with the Japanese producers who dominated the field, and quietly accumulating the institutional knowledge that mass production would eventually require. That investment took 30 years to produce T1200 grade industrial output. 30 years, no quarterly earnings call, no shareholder pressure to show returns. Just a 30-year commitment to a material that would matter when the world was ready for it? Now here's the part that makes this bigger than carbon fiber. The same logic applied to everything else. Vanadium, manganese, niobium. China did not become the dominant processor of those materials because it had the most ore. It became dominant because it made the infrastructure investments that turned geological resources into industrial supply chains before anyone else recognized those supply chains would be the bottleneck. The input dominance was not accidental geology. It was a deliberate strategy, executed quietly, while the West focused on the finished products those inputs enable. And the patent walls followed the exact same pattern. You do not file patents defensively when you are already the dominant producer. You file them aggressively when you are approaching dominance to legally encode your production methods before competitors have matched your capabilities and can design around your filings. China's patent acceleration in green steel and advanced carbon fiber did not happen after the breakthroughs. It happened during them. The legal enclosure and the factory construction happened simultaneously. By the time the West noticed the factories, the efficient routes through the technology were already legally claimed. Here is the detail that puts everything into perspective. This is not just a manufacturing story. It is a story about what happens when a nation treats materials science as a geopolitical strategy. When the question is not what we can sell today, but what will the world need to build within 50 years, and who controls the ability to build it? Western nations have engineers. Germany's metallurgical science is world-class. American aerospace research produced some of the most significant carbon fiber advances of the 20th century. Japan built the carbon fiber industry the rest of the world relied on for decades. None of that capability vanished. What changed is the time horizon. Private capital optimizes for a 3 to 5 year return. Advanced materials development operates on a 30-year one. That mismatch is not a failure of intelligence or ambition. It is a structural feature of how Western economies allocate resources, and China built its entire materials strategy around exploiting exactly that gap. Patiently, methodically, one 5-year plan at a time. So here is where you actually are right now. You are living through the moment when the material foundation of the next century of manufacturing is being decided. Not debated, decided. The carbon fiber that builds the aircraft of 2040. The advanced steel shaping the vehicles of 2050. The green production methods that determine which nations face carbon tariffs and which ones sail right past them. China has already positioned itself at the center of all of it. The factories are built, the patents are filed, the inputs are controlled, The price floor is set. The question is not whether China has already won the materials war. The question is whether the West has noticed it started.